going to prove some not so famous laws. Going to first look at the law of tangents, which says in any given triangle that a minus b over a plus b, this is nothing more than the tangent of a minus b over 2 divided by the tangent of a plus b over 2. So to prove this, so that's the theorem. So to prove this, we're actually going to use the law of sines. We know that the sine of a over a is equal to the sine of b over b is equal to the sine of c over c. But these all ratios equal the same value. After all, it has equal signs. And we'll call that value k for constant. So this equals k. That is, the sine of a over a equal to k. Well, we're allowed to switch those two. The fact of division. 10 over 2 equals 5 because 2 times 5 is 10. If you switch them, well, let's actually switch them. 10 divided by 5 is also 2. And the reason is because 2 times 5 equals 10. You can switch them, okay? So this tells me that the sine of a over k is equal to a. We also know that the sine of b over little b is k. So that tells me that little b is sine of b over k. Likewise, sine of c over k is c. Now, let us compute what we want. We want a minus b over a plus b. Well, a is sine a over k minus b, which is sine b over k, all divided by a plus b, which is sine a over k plus sine of b over k. And the first thing I realize is that if I multiply by k, top and bottom, the k's cancel out. That is, I just get sine of a minus sine b over sine a plus sine b. So let us get rid of a lot of this stuff. So the left side, a minus b over a plus b, is nothing more than this. The sine of a minus the sine of b over the sine of a plus the sine of b. But we have a formula that goes from the sum and difference of signs to a product. The numerator is 2 times the sine of, should be a minus b over 2 times the cosine of a plus b over 2 divided by the sine of a plus b. And the sine of a plus b is just 2 times the sine of a plus b, sine of a plus b over 2 times the cosine of a minus b over 2. And first notice that the 2's cancel. And we pretty much have it at this point because this division right here is the tangent of a minus b over 2. And this division right here is, in the bottom, the sine of it, the tangent of a plus b over 2. And we will be done if this equals this, and it does. So we verified that this really does equal that. Now let's go on to the first of Mollweid's theorems. Let us consider the first one. First one talks about a plus b over c. Well, we just realized what that is. A is sine a over k. Well, first let me state the theorem. I apologize. This is equal to the cosine of a minus b over 2 divided by the sine of c over 2. This is what we want to show. What is a plus b over c? Well, little a is sine of angle a over k plus the sine of b over k all over the sine of c over k. And once again, the k's cancel. So we get the sine of a plus the sine of b all over the sine of big C. But we know what the sine of a plus b is. It is 2 times the sine of a plus b over 2 times the cosine of a minus b over 2. Now, I'm going to think of C a little bit differently. I'm going to think of C as, I want to think of it as a double angle. C, so this is equal to the sine of 2 times C over 2. So it's 2 times some angle. The angle being C over 2. So what do we get? Over 2 over 2. So we get 2 times the sine of the angle times the cosine of the angle. And this cancels out. And let's see what we have. We have this piece right here without that 2. We have this piece right here. That's exactly this. So we're going to safeguard that. So what we have right now is the sine of a plus b over 2 all over the cosine of c over 2 times exactly what we want. That means that other piece has to be 1. The left bracket has to be 1. So let's copy down the left bracket correctly. What's in blue is now in the right bracket. Let's actually put it in blue. And everything else is not in their blue brackets. I want to show that this piece is nothing more than 1. Because then I can cross it out. Multiplying by 1 doesn't do very much, does it? Okay. So here's how we're going to continue. Just want to see one thing. So I really believe that. I apologize. My goodness. Let's write down what's in blue. The cosine of a minus b over 2 divided by the sine of c over 2. That's exactly what is up here, times some other stuff. The other stuff is the sine of a plus b over 2 divided by the cosine of c over 2. So I want to show what's in that bracket cancels out to 1. Well, let's just write everything else. Okay. Times the sine of a plus b over 2. Now, we know that angle A plus, we know that angle A plus angle B plus angle C is 180. This tells me that angle C is 180 minus A plus B. So that's exactly what I'm going to plug in for C here. It's over the cosine of some angle over 2, C over 2, where C is 180 minus A plus B. This is equal to the front piece that we plan on safeguarding with our life. Times the next bracket. Okay, so we have the sine of a plus b over 2. I didn't change anything for the numerator. Now for the denominator, I'll do some division. 180 over 2 is 90 minus a plus b over 2. Now this is where everything comes together. So we have the cosine of a minus b over 2. Not sure what happened to that over 2. Divided by the sine of c over 2. Not gonna touch that. Times the sine of a plus b over 2. Over something else. Now, remember, if you have the cosine of 90 minus k, this is equal to the sine of k. We proved that earlier. That is, the sine of 90 minus anything is the sine of the anything. The anything is a plus b over 2. So I get the sine of a plus b over 2. I now smile because that's going to cancel out, and I am going to get just what I want. As long as I write it correctly, I'm going to get the cosine of a minus b over 2 divided by the sine of c over 2. And there it is. That is the first of Mollweid's theorem. Let us now prove the second theorem of Mollweid's. The second theorem goes on to say the following. It says that a minus b over c is equal to the sine of a minus b over 2 divided by the cosine of c over 2. This is what we want to prove. A minus b over c, this is just like before. It's sine a minus sine b over the sine of c. Now, what is sine a minus sine b? You have a difference of signs. You can write it as a product. It's the cosine of a plus b over 2 times the sine of a minus b over 2. 2 times that. Divided by, going to play the same trick. We're going to think of c as c times, 2 times c over 2. So this is going to be 2 sine c over 2 cosine c over 2. Double angle formula. It's 2 sine c over 2 times the cos of c over 2. The 2's cancel out, and you get rid of this in the bottom, and let's see what is going on. We want to safeguard this, because that's exactly what we want to get. That is, everything else, this fraction right here, is going to have to equal 0. And we'll do the same game as before. We have the cosine of a plus b over 2 divided by the sine of c is 180 minus the other 2 angles over 2 times what we want, times the sine of a minus b over 2 over the cosine of c over 2. To quicken this up a little bit, this angle becomes 180 over 2, which is 90, minus a plus b over 2. And the sine of that is the cosine of a plus b over 2. So we get what's in the numerator, the cosine of a plus b over 2, divided by the sine of this, which is the cosine of a plus b over 2, and let's change the color, times this stuff, the sine of a minus b over 2, divided by the cosine of c over 2. And this cancels out, and we get the sine of a minus b over 2, all divided by the cosine of c over 2. And there it is, done. We proved both Mollweid's rule and the alternate Mollweid's rule, or theorem, excuse me. That completes this part of the lecture.